Continuous X-rays. Continuous X-rays are the X-rays which are produced due to deceleration of a charged particle due to interaction of a nucleus of atom. The continuous X-rays are usually described by the deceleration of electron. So when an energetic electron passes through the nuclei of an atom, the nucleus of an atom interacts with the energetic stream or a beam of electron. So due to interaction of a nuclei with negatively charged electron result into an attraction force between a nuclei and an electron, and due to interaction force of the nuclei with electron result into deceleration, result into decrease in acceleration of electron. And when the acceleration of electron decreases, this deceleration result into emission of electromagnetic radiations. And these electromagnetic radiations which are emitted due to deceleration of electron by interaction of a nuclei is known as continuous X-rays. Continuous X-rays are also known as Bremsstrahlung radiations. Dear student, Bremsstrahlung, the word Bremsstrahlung is a combination of two words. And these two words are bremsen, which mean to break, and Strahlung, which mean radiation. So in a combination, Bremsstrahlung radiation mean breaking radiation, and that's why continuous X-rays are known as breaking radiations. Dear student, the word break means to stop. So this means that due to interaction of electron with a nucleus, the acceleration or the speed of the electron or the energy with which electron is moving from an atom is basically decreased, and due to decrease in energy, speed and acceleration of electron result into an emission of radiation, and that emitted radiation is known as Bremsstrahlung radiation, breaking radiation, or continuous X-rays. So in a simple word, dear student, Bremsstrahlung radiations or continuous X-rays are a type of electromagnetic radiations which are produced when a charged particle is deaccelerated, when a charged particle moves, or when a free charged particle moves near a nucleus, or in a simple word, when an electron, a free electron, moved near a nucleus, deaccelerate due to an interaction of a nucleus, will result into an emission of electromagnetic radiation, and that emitted electromagnetic radiation is known as continuous X-rays. Now let us discuss about the necessary conditions, or how we can basically generate a continuous X-rays. Basically, dear student, continuous X-rays require an electron gun or a source of a generation of stream of electron. So this source is very important for generation of electron. So with electron gun, which is basically a device which produce highly energetic stream or a beam of electrons. So these beam of electron have very high kinetic energy, and these beam of electron are basically accelerated in a device which is used to generate continuous X-rays. So the stream of a beam of electron which is basically generated in electron gun, which is an electron generation source, is accelerated in X-rays device. The acceleration of the stream of the beam of electron is usually done in X-ray devices by using different types of combination of anodes. These anodes are accelerating anode, pre-accelerating anode, and even for focus Fresnel cup is also used. So in continuous X-ray devices, initially a source is used to generate a stream of beam of electron, and that source is known as electron gun. So from electron gun, the electron are accelerated by a combination of different types of pre and post accelerating anodes and Fresnel cup. And after that, the stream of a beam of electron is basically bombarded on a metallic anode. Basically, metallic anode is a kind of a source material from which a continuous X-rays will be generated. So now, when the accelerated beam of electron is basically bombarded on a metallic anode, they will result into de-acceleration of these highly energetic beam of electron. So now, due to de-acceleration of the beam or a stream of electron due to interaction of a nuclei of an bombarded atom, will result into an emission of electromagnetic radiation, and that emitted electromagnetic radiation is continuous or braking or Bremsstrahlung radiation. So in a simple word, initially, in order to generate a continuous X-rays, we need a source of a generation of stream of a beam of electron, and this stream of a beam of electron is accelerated inside the continuous X-rays generation device. And when the stream of a beam of accelerated electron interact with target material from which we want to generate a continuous X-rays, will result into de-acceleration of stream of beam of electron. Since, as you know, that according to the law of conservation of energy, initial energy is equal to the final energy. So the total amount of energy will remain conserved. So the initial energy of the stream of a beam of electron when it moves across a nucleus decreases, will be converted into electromagnetic radiation, and that electromagnetic radiation is known as continuous or braking or Bremsstrahlung radiations. Dear student, just for your information, continuous X-rays or any type of X-rays are generated in X-rays tube. So this is a schematic representation of X-rays tube. Usually the X-rays tube consists of a cathode and anode. Please note that cathode is an electrode from which a stream of a beam of electron are generated and accelerated toward the anode. Whereas anode is a target in X-rays tube. So the cathode generate a stream of beam of electron, and these electrons are accelerated and bombarded onto the surface of anode. So when the stream of the beam of energetic electron bombarded onto the anode, these at the surface of the anode, which is basically have a combination of millions and even infinite number of atoms, when the stream of the beam of electron, in fact, there is a possibility of the de-acceleration of the stream of beam of electron in near the surface of the anode or near the surface of the target material. So due to de-acceleration of the electron will result into an emission of X-rays from the X-rays tube like this, and these emitted X-rays are due to a de-acceleration electron are known as continuous X-rays. So now let us explain X-rays tube schematic diagram in a brief way. Basically, X-rays tube consists of a cathode. Okay, this is a schematic representation of a cathode. The student, cathode is an electrode from which electrons are generated. So the student, please note that the cathode is connected with a highly electric potential source, which is basically this is electropotential source. Usually it's operate at direct current potential. So the cathode will produce a stream of a beam of electron. Usually cathode is made up of tungsten material. It is made up of tungsten, and it is made up of tungsten and which is basically work on a liberation of electron due to a thermionic emission. So the tungsten cathode is connected with a filament, and that filament is work on thermionic emission process. So when the electric potential is applied on a filament, it is somewhere here, and which is also made up of tungsten material, the electric potential is quite high. So due to a very high electric potential, this will be result in the resistance of the filament will basically cause a very high temperature. So cathode is near the filament. This one is filament, and this one, and cathode is near the filament. So the cathode will heat up due to the high potential or due to high temperature of the filament. So when the cathode get heat up, the cathode will result into an emission of electron due to a thermionic emission process. Now this cathode has emitted the electron. Now question here is that electrons are emitted, but how we can increase the energy of electron? And made the electron very energetic in order to get a very shorter wavelength of continuous X-rays. For this, a combination of anode are used in cathode in X-rays tube, like this. The anode are known as accelerating anode. This one is accelerating anode. Okay, this is anode. Okay, and so a combination of anode are used near the cathode material. So the anode are positively charged, whereas the electron from cathode are negatively charged. So they will result into an increase in acceleration of the electron which are produced from the cathode. So now the combination of the anodes will result into speed up of the electron. So there is also a device which is known as Wehnelt cup, which is used in X-ray tube. The Wehnelt cup will also focus like this one will focus the stream of the electron, W cup. Okay, this Wehnelt cup will speed up and focus the electron beam onto the surface of the anode of the X-ray tube. So now these electron, it's a highly accelerated beam of electron when interact with the surface of this anode will result into a generation of different types of X-rays. They will result into generation of characteristic X-rays and also continuous X-rays. So in order to discuss a continuous X-rays, the stream of beam of electron when they fall on the surface of this anode, the stream of the beam of electron have a certain kinetic energy Ke, and this Ke when interact with the surface of the anode will be decreased, and the kinetic energy will be converted into Ke dash, like this. So this means that the kinetic energy is basically decreased, and that deaccelerated kinetic energy will be conserved and will result into emission of electromagnetic radiation, and these electromagnetic radiation are known as continuous X-rays. So dear student, if I discuss the if I discuss the X-rays tube which is used to generate a continuous X-rays, the student please note that X-rays tube consists of a tube which is evacuated. Okay, this one is a tube, and this tube is usually evacuated, and this tube consists of a cathode and anode. These cathode and anodes are highly potential connected with highly potential difference. So when a high potential difference between a cathode and anode is applied, this high potential difference will result into a generation of a stream of a beam of electron, and this stream of the beam of electron is basically accelerated by the different types of adjustment of the anodes, which are known as pre-accelerating anode and accelerating anode, and then the stream of the beam of electron is focused on the surface of the anode material. So if the stream of the beam of electron which have a certain amount of kinetic energy is decreased, then this decrease in kinetic energy will result into emission of electromagnetic radiation, and that emitted electromagnetic radiation is known as continuous X-rays. Student, please note that usually the combination of cathode and pre-accelerating and accelerating anode and Wehnelt cup in X-ray tube is known as electron gun. In order to understand the electron gun, you can basically follow our lectures about the combination and about the setup of the electron gun. which are used as a source of generation of electron. In a simple word, please note that in X-ray tubes, usually the stream of the beam of electron are generated due to an adjustment or due to a setup of the electron gun which is used in X-ray tube. Usually the electron gun is a combination of filament which basically which emit a high temperature or which produce a heat due to a high potential which is applied across the filament, and due to high potential the filament get hot up, and the right hot filament emit heat, and the heat just reach to the cathode, and due to a high temperature cathode will result into an emission of the electron stream, and that electron stream is then accelerated by the accelerating anodes, and these accelerating anodes will speed up, and whereas there is a Vanel cup which will focus the stream of the beam of electron onto the surface of the anode. And as a result, when the stream of highly energetic beam of electron interacts with the surface of anode, if the stream of the beam of electron acceleration decreases, then due to deceleration or due to decrease in speed or acceleration of the electron will result into an emission of continuous X-rays. So this is just an overview of X-rays tube which is used to generate characteristic and as well as continuous X-rays. So now let's discuss about the essential internal parts of X-rays tube. What are the main parts of X-rays tube which are used to generate characteristic, continuous, soft and hard X-rays in X-rays tube? Dear student, please note that X-rays tube consists of a filament. So this is a filament. Usually the filament of an X-rays tube is based on tungsten, and the filament is connected with a high potential source. The potential source is usually based on direct current, and it operates at hundreds of kilovolts. So mean that the potential applied on heating filament inside the X-ray tube is quite high. Due to a high potential applied across the filament of the X-rays tube will result into thermionic emission, or will result into red hot filament. So due to high potential, the filament of the X-ray tube, this filament will become a red hot. Okay, so now this red hot filament is basically will cause an emission of the will cause a heat inside the X-ray tube. Please note that there are also usually in industrial setup, these filament also have a different types of cooling setup around it. But for simplicity, in the X-rays tube basically consists of a filament which work on thermionic emission of a heat due to a high potential. So this thermionic emission will basically, the filament will cause a thermionic emission or emission of very high temperature heat. The filament of an X-ray tube is basically connected with cathode. So this red schematic represent a cathode. So when the filament is heated by the potential source, the therm mean the heat will be emitted from the filament, and that heat will be interacted with the cathode material. Cathode material is also usually made up of metallic material, and it is usually tungsten. So this cathode will basically remove or will emit a stream of electron due to thermionic emission process. Dear student, please note that the X-ray tube consists of a target material, and the target material is usually known as anode. So target material is high connected with a high with a positive terminal of the potential source. Since now, please note that when high potential is applied on the filament, this high potential will cause a flow of the electron with high current inside the filament of the X-ray tube, and this will result into a very high temperature, and this will result into emission of a heat from the filament of the X-ray tube. So now the electron or the current is moved across the filament, and the filament basically the current is basically some of the current is basically lost due to a resistance of the filament, which will result into a production of a heat. These yellow lines, these spots basically, these represent the heat which is basically emitted from the filament of the X-ray tube. So the basically electron movement or the current movement across the filament will basically cause a continuous emission of the heat from the filament. So this heat basically is quite high because the potential applied across the filament is quite high. So when the heat interacts with the cathode, with this cathode basically will result into emission of the electron. Student, please note that I have told you that this cathode consists is metallic. Okay, so the metal, it is a metal. The cathode is metal, so this metal have a free electron on its surface. The electrons are loosely bounded and they move freely on the surface of the metallic material. So this freely moving electron will gain the energy from the heat which is emitted by the filament, and the binding energy, since if the potential is quite high and heat is quite high, then the binding energy of the electron, which combine the electron to reside on the surface of the metal, is become less than the energy produced due to heat. And if the binding energy of electron which is residing on the surface of the cathode is less than the energy provided by the heat from the filament, then the electron from the surface of the cathode will be emitted, and this electron will move toward the positively charged anode like this. So now the electron will move from cathode toward the surface of anode, which is positively charged. So when these highly energetic electrons interact with the surface of this anode, will result into an emission of different types of X-rays like this. This is schematic representation of X-rays. So these X-rays may be crystallographic X-rays and as well as continuous X-rays. In order to produce continuous X-rays, dear student, these accelerated electrons which move toward the surface of the X-ray, toward the surface of the anode, if the accelerated electron on the surface, the energy of kinetic energy of the accelerated electron on the surface of the target or on the surface of the anode decreases, then the decrease in kinetic energy will result into a production of continuous X-rays. So this means that if the stream of electron which come from the cathode toward the surface of anode, if the acceleration of these electron decreases on the surface of the anode, then they will result into an emission of continuous or breaking or brownstalling radiation. So, dear student, please note that the electron which are basically produced at the surface of the cathode, they are accelerated toward the target or toward the anode by different types or different combination of setup of anode. These anodes are basically adjusted in a different ways in X-ray tube at a different angle. So since you know that the anode is positively charged, so electron will they will result into move the electron faster toward the surface of the target or to the surface of the anode material. So when the electron move faster, they will interact very fastly with the surface of the anode, and if the interaction of the electron with anode, with the nucleus of the atoms of the anode material, if they result into decrease in the acceleration of the accelerated electron from the cathode, then due to deceleration of the electron will result into a production of continuous X-rays. So now if we explain in a simple word, if we explain the internal setup of X-ray tube in a simple word, student, X-ray tube consists of a heating filament, and this heating filament is connected with a high potential source. Near the heating filament there is a cathode. Cathode is metallic and it is made of metal which can easily liberate or which can easily emit the stream of electron. So the filament basically provide a heat, and that heat is basically transferred onto a cathode material, and when the cathode material get hot, the cathode material result into emission of a stream of electron. The stream of electron is accelerated by different types of setup of anode, which are known as pre-accelerating anode or accelerating anode, and then the stream of the electron is transported onto the surface of the target anode material. And if the stream of electron interact with the target anode nuclei, and if the energy or if the acceleration of the incident stream of electron decreases, then they will result into an emission of X-rays, which are known as continuous X-rays or brownstalling X-rays or breaking radiations. So this is just an overview of internal setup of electron, internal setup or internal port, which are essential in X-rays tube. So now, let us briefly explain schematically that how an X-rays, continuous X-rays are produced from an atom. Dear student, please note that an atom consists of a nucleus. A nucleus is a combination of nuclear particle known as proton and as well as neutron. proton or positively charged particle, whereas neutron in a nucleus are neutral charged particle. Student, please note that overall the charge on a nucleus is positive. This is for simplicity that a nucleus consists of a proton and neutron. So this is a statement for simplicity. Please note that nucleus consists of also other subnuclear particles which are present in a nucleus. However, for making the topic easy, just consider that a nucleus consists of two nuclear particles, and these particles are proton and neutron. Protons are positively charged particles and neutron are neutral. So overall the charge on a nucleus is positive. Atom consists of an electron, and electrons are present in energy levels, and these energy levels are present around the nucleus. The first energy level around the nucleus is known as K shell. Dear student, the first energy level, which is known as K shell, consists of maximum number of 2 electrons. Every energy level in an atom consists of sub-energy levels, and these sub-energy levels are known as subshell. The first energy level, which is known as K shell, consists of one subshell, and that one subshell is known as 1s2 subshell. 1 represents a first energy level and S is a subshell. So 1s2 means the first subshell has maximum number of 2 electrons. So dear student, the first cell of an atom consists of, which is K shell, consists of maximum number of 2 electrons. Second energy level around the nucleus is known as L shell. The L shell has 2 subshells, and these 2 subshells are known as 2s2 and 2p6. 2s2 mean 2s2 subshell has 2 electrons, and 2p6 subshell mean 2p6 subshell has maximum number of 6 electrons. So the total number of electrons in second shell, which is known as L shell, is 8. Third shell around a nucleus is known as M shell. Third shell, M shell, consists of 3 subshells. These subshells are 3s2, 3p6 and 3d10. 3s2 subshell has maximum number of 2 electrons. 3p6 subshells has maximum number of 6 electrons, whereas 3d10 subshells have a maximum number of 10 electrons. So maximum number of possible electron in M shell is 18. So since I am discussing the generation of continuous X-rays from an atom, so I am giving an example of sodium atom. Since you know that maximum number of electron in sodium atom, or the total number of electron in sodium atom, is 11. So the atomic number of sodium atom is 11. Since the first shell, K shell, has 2 electrons and whereas second shell, L shell, has 18 electron. So already K and L shell have 10 electron. So there will be only one electron in third energy level M shell for sodium atom. Okay, the M shell in a sodium atom is known as valence shell, and whereas the electron in M shell of sodium atom is known as valence electron. So now let us discuss that how we can produce a continuous X-rays from a sodium atom. Since I have discussed that a continuous X-rays are produced when energetic stream or a beam of electron are deaccelerated by a nucleus, or when an energetic stream or a beam of electron pass near a nucleus, the interaction of the nucleus cause a deacceleration of electron, and that deacceleration energy or deaccelerated energy is converted into electromagnetic radiation, and that electromagnetic radiation is known as continuous X-rays. Let us represent it by animation like this. So dear student, the stream of the beam of electron is incident on a sodium atom. So when the electron pass this electron which has very high kinetic energy, when it passes through a nucleus or pass near a nucleus, the nucleus will basically interact with a stream of the electron. Please note that the nucleus has a positively charged particle, so the nucleus produce a electric field of lines, and similarly the electron which are moving, or a stream of electrons which are moving from near the nucleus, they have also electric field of lines. And so these both the field of lines from positively charged nuclei and the field of line from the electron, they basically interact with each other, and due to interaction of this nucleus and the stream of beam of this electron will result into a deacceleration of this electron. Like this means that the speed of the electron is quite high, but when it's passed to the nucleus it will decrease, and when the acceleration of the electron in decrease, this will result into a generation of a continuous X-rays like this. So this is a description of, or an animated description of, a generation of a continuous X-rays from a nucleus.